Yeah. Hello, everyone. We're the Wellesley team, and we developed a product that translates SQL code into natural language. Okay, so the business world runs on three things: spreadsheets, disgruntled interns, and SQL. SQL, which stands for Structured Query Language, allows users to query a database. It's easy to learn, but faster.
Wait, I have to ask. Can you go back to that slide? I really have to ask. Who got this insight here? This is so accurate. Who got this insight here? This is.
I wrote this down.
Yeah. Jeremy, this is good. This is good. Yeah, and it's very, very accurate, actually. Yeah. Okay. All right. Okay. Sorry.
So our solution is we can translate SQL to our natural language, which is English. So here's an example of what our model does. Basically, you input an SQL statement, and then it will translate it to what like a human understandable sentence or question or phrase that the SQL was aiming to solve. Right. So here are the benefits. It makes it easier to learn SQL, which is what we refer to when we call it keeping the learning curve flat. And then it's also will be a great resource for small businesses trying to expand and learn SQL to solve their data needs. Makes them more efficient, saves time and money because they don't have to hire expensive analysts to understand what's going on. And by providing a simple way to learn one of the most pervasive technologies of the 21st century, which is SQL, small businesses, startups, and organizations are enabled to use data-driven methodologies to expand their enterprises.
All right, so I'll speak a bit to the methodology that we used. In true agile fashion, we made a crappy product first that didn't really work, and we kept on iterating from there. So we started off actually wanting to build a code generator, but after realizing that we had neither the expertise nor the time to really make that work in a way that would be useful to people, we decided to go with something that had, one, a lot of data already, and two, we thought we could actually do. So we chose SQL to natural language translation. Started with transfer learning, which is basically we take a pre-made model and we give it new data and we train it. So it adjusts to a specific domain. So we did that with GPT-2 from OpenAI, but we realized that was not actually the best model to use. And so after many iterations, and we chose sequence to sequence, which we only just implemented, which has a better architecture. It's meant for machine translation. All right, back to Sophia.
All right. So as you can see, our product in action here, here's our chunk of SQL code, which says select third place from table where fourth place equals South Melbourne. That says who was third place in the game where South Melbourne was fourth. And our other chunk of code says select away team from table where home team equals South Melbourne. Basically, it's going, who was the away team in the game in which South Melbourne was the home team. And as you can see, our model can translate that into our language, which someone can just read and understand pretty easily. And our model is accurate, but it could be more precise.
So to that point, there's still a lot we can improve. And a couple of things that we could do for that are as follows. That in the model, we just pass the raw language, so raw SQL, to the neural network. And it doesn't preserve the structure of the SQL statement or even like give it any information about the database that it's working with. So that could definitely help. And that data is indeed available. Another way to make it a lot better is to use a larger neural network with a whole lot more examples. which is pretty much a rule of thumb with a lot of different models. And it is important to point out that the sequence-to-sequence architecture in general, for any problem that you apply it to, has the negative trade-off that it can only interpret words that it already knows, which, I mean, that plagues most machine learning models. It can only deal with stuff that it learned from or similar to what it learned from in the training. Cool, thank you. Now to the demo. Hopefully we're running all right on time. I will point out that the model that we trained, we finished training this morning and it didn't actually save correctly. So this is actually at 70% accuracy instead of 85. We'll see how it goes. So here's our website. Here, let's come up with something. So I select player from table where maybe team is equal to Michigan. Let's see. Probably not, yeah, okay. What is M when deaths is team? So that's something. Yeah. We'll give you all an update after we get back up to 85%. But my MacBook can't handle it that quickly. All right, let's try another one. Here, I'll look at a couple examples that may or may not work. Select rank. Okay, select rank from table where nationality equals Zimbabwe. What is okay. Yeah, a little bit less coherent, but you got the picture hopefully from the slides. And we'll be sure to update the model and put it and swap it out. Yeah, thank you everyone.
I was just saying in the chat, the real world applications for that are really crazy. I'm combining it, of course, with what I know, which is teaching. So being able to have a student look at a piece of code, and usually the first time anyone looks at code, they're like, what is this? It looks like a totally separate language. And being able to say, no, it actually just means this. That's really, really cool.